So what's up, guys? I thought I'd make this video on editor working on, so I'll tell you the story. So actually I'm the author of this book here, programming microcontrollers with Python. And it actually uses CircuitPython. And though I personally I don't use CircuitPython like every day, I probably use it for small projects. And it's what I recommend to people when the time they're not getting started with embedded systems, like they're now starting off. I kind of always tend to recommend, CircuitPython for them because it makes it really easy for them to get started. And one of the things I like in the ecosystem is, Mu editor. Like even in my book, one of the first things I talk about is Mu editor. This nice editor that you could actually use, real beginner friendly and stuff. But recently, when I was looking to recommend someone where to use it, I realized it was sunsetted, right? Like Mu is no longer made. So without diving too much into it, I started the Rovari platform, and there's a platform for actually RISC-V, and it's supposed to be like abstraction layer on top of all the vendor stuff. So that began to get started, and I was like, you know what? We already have, already adding C, C++ support, already adding abstraction layers. I might as well drop, CircuitPython into the stack. So about a month or so, I actually started, adding CircuitPython support into the editor, and decided to break out, CircuitPython into its separate editor built on top of the Rovari platform, right? So the platform will encompass not only C and C++ support, but also Python supporting from CircuitPython. So I've been testing on this, this little Pico here, and working on right now, the Bluetooth and Wi-Fi integration. So with the ESP32C3, yes, I will be supporting like legacy ARM boards and stuff with the editor, like any CircuitPython board. But RISC-V is first class citizen, so of course RISC-V devices, I plan to give a lot more extra testing, and especially these ESP devices, they kind of have Bluetooth and Wi-Fi and stuff, so you kind of need to use that into the workflow rather than the traditional boards that just have this. But forgetting for now, I just want to have a good desktop IDE, that the CircuitPython community that we could use, that kind of encompasses some professional features that I felt was personally missing from you, right? So I'll jump into the editor so we can kind of look at some of the features of the editor and stuff. So guys, this is the editor. This is Rovari Circuit Studio, and it's of course based on the Rovari platform that's for RISC-V, Rovari for RISC-V, and it's designed to be really easy. I kind of take a page out of Mu's book. It's designed to be really simple. Of course, it's alpha level software right now. Probably about 30 to probably 40 days out for public release. But it's just a sneak peek to kind of show the editor, probably get some feedback from the community, and kind of look moving forward, the direction the editor should take, right? So, you have your standard editor stuff. So I think the first thing I'll do is like plug in the board. So right now, unplug the board so you can plug it in. So I'll just refresh so you can see. So it have no board, nothing. Um, we plug in the board, right? It of course will automatically detect as soon as you plug it in, and open the drive for you. And of course, you have your code.py. This is the Blinky that I had actually running on the board. The editor has a lot of features that I think you'll be accustomed to. So of course we have Control S to save. We have you could create a new project in your workspace. You can actually open a project, new file, save as. We kind of have, we could close stuff. And of course the ESC AT system, but this is a kind of stripped down version of the model editor platform I built. So you could kind of toggle your Explorer window, your snippets window, and the code editor. I left out toggling the terminal for CircuitPython because it's kind of the terminal is kind of way working. So, but you could adjust it. Like everything is adjustable, and and the editor will kind of save we will save state. It's very responsive, and you'll have no problem with that. Of course, you could adjust things like a text size, Control++. control minus minus, and it's persistent. So it'll save across closes and stuff like that. Um, undo, redo, select. We have indent if you wanna, it's press tab to indent. And then because of Python, we have shift and tab for the let's get this for the dedent, right? So indent and then you dedent, right? Um, of course we have, your normal shortcuts you expect. You could create files, you could create folders, rename stuff, delete stuff. Um, and you know, I kind of want to go through some of the other stuff on the toolbar. So we have the standard stuff here. We have this run green arrow here. So this is actually to run, save and run stuff on the board. This is actually a code formatter. So let's say you have your ugly Python. Let's pick the formatter, and it will format the code for you automatically. So actually have a library manager. The library manager is, where you'll kind of be able to install all your bundles and stuff without you having to, you know, kind of manage it yourself. So click the library manager here. I already have I2C installed, but you could browse the bundle to, download the bundle for you to check, and you get other libraries here. You as a user don't have to do anything. When you file library, let's run add SPI. Um, that's regular SPI I install selected. It installs on the board for you. You see it's here. And it's in, of course, the lib folder on your board, right? So you don't have to worry. And of course, save the same thing with installing. So you have it here, remove, right? And it's removed, and it's removed from your lib. So you could easily manage your libraries. It will download the bundle for you. And this bundle actually detected based on the version of your board, right? So on boot, you can detect your board version, and from your boot order text. And based on this version here, it kind of determines which version of the library that you should use without you having to do anything, right? Um, we have a lot of stuff to cover. So one of the things you'll notice is we have this save file rights. So one of the biggest gripes with CircuitPython using is that most people talk about is until like destroy a project, right? So every time you save the CircuitPython board, there's a window, and especially on Windows, you have several seconds where your data is sitting in like the OS buffer, and it not written to flash yet, right? So if the board get reset unplugged during the that window, your code that py file actually get corrupted. And it's just silent, no one in your code is just gone, right? Sorry, it's something that I experience in Mu a lot, and it's something I really try to avoid here. Um, and Thonny had the same thing. Mu and Thonny is the same thing. So I was like, when I build in this Rovari Circuit Studio, with CircuitPython support, how to make sure we get that. So the moment you press save, um, you know, when you save stuff, it will, you'll see like a workflow. So it'll tell you the board is you have to remove or not. And once it's saved, you'll see save. But if something happens, you'll actually see it will tell you that it failed or it's not safe to remove. And actually, did a system where it kind of does like a temp and a verification process any copying of, like, I won't get into technical details, but it's a way to kind of help with the flushing system, so you kind of don't have to worry about um you know corrupting your file. It's not foolproof, but it's better than nothing like what we had before, right? So now you could unplug, you could reset, and the file is safe. And I don't really see any other CircuitPython IDE with something like that. Um, so I guess I could kind of get into some of the other features. So let's say you spell something wrong. You Control S, to kind of highlight the error for you, so you get your error highlighting. Um, right now, so we'll start this again, right? Right now the board is running, so some people want to use a REPL, or REPL, however I pronounce that. You evaluate print loop. And I kind of have this run mode, stop mode thing. So right now it's in run mode. When you click, it's in stop mode. And you see on the bottom here, you kind of have, any key under the ripple, and you kind of get directly into it. So, you could print, um, you know, true. Sorry, I kind of, typing and typing, right? And you kind of get the, your stuff. So let's do it properly, right? And, so you kind of get your ripple to your customer. When you're done, you press this back and you enter boot now. Yes, so you could do a control C, your custom with, and in a control D, right? The top that you always are accustomed to, but this here of course makes it easier, and you could use either one. It will always end up in an unlock state. Just keep pressing this button and your code will reboot and run, right? Um, so what else could I cover? So much. Oh well, we could cover settings. We have a settings here, where you set in your tab, but I have two, but four, is of course where it is. You have your workspace, right? And of course, your board, you could, for the older boards, we have the main.py, but like I said, going forward with the newer stuff, right? Um, so that's just stuff with this, so it's be a simple editor. And of course, you have the snippets window where you could actually come here and you could actually, so let's say you want a PWM pattern. You kind of get your pattern, so you don't have to worry about it. I'm working on your integration, but for now, the snippets window is where it is, because I had to consider API costs, and for them I do a pro version of the studio that have the AI features, because it will be kind of pricey to run, and just give. But yeah, so this is where we are with this. There's a lot of stuff I could get into, but then we'll just be saying basically going through a text editor, right? Well, I should probably show you, actually have a plotter. So I'll do a little program here, because the plotter was kind of a thing I wanted. So let me get this. I have an example already wrote. Um, so we backspace this, we do Control S, and we have the here. And then if you go on plotter, we actually have this nice and actually have several examples running. So we have this plotter here that will actually show you stuff. You could of course pause and resume the plotter, and you can adjust the window size. 200 is a nice view. And it kind of supposed to be a upgraded version of what you had. And I think a lot of people appreciate the serial plotter. So this is, like I said, this is our first look. A lot of stuff still have to work on. I have a lot of testing to do, a lot of integration. And of course, you have to kind of tie back into the ecosystem. And I even hoping to get some, like I say, for RISC-V especially, some first class features with in terms of your pinouts. And I want to have a little thing on the side here. We can actually see a pin, probably a simulator. It's a lot of work. So I'll keep you guys posted. Like I say, even this release, um, will be like a beta release. I'll put it on GitHub. Of course, package for release across, initially Windows and eventually Mac OS Linux. Because it's really sad that Mu have no replacement. I mean, I can't blame them as volunteers. It's kind of difficult to just volunteer time, because something like this will take a lot of time. Um, this particular platform here, I started working on Rust System Studio. That is almost probably going in 3 years now, and that is the base I used to build this on, right? But it is written in full Python. So I kind of try to get the Python aspect of it, and actually started with PyQt5, and then PyQt5 was discontinued in 2023. So I had to go through the arduous process of porting everything to PySide 6. And we are at this point now. So this will be complementary to Rovari Studio and Studio Pro. And this will be for CircuitPython support, with of course RISC-V being first class. But all the boards are accustomed to the ESPs, the Adafruit boards. Of course I want to support everything, but I rather support a few stuff that are not tested, that are not working, than try to support everything, and everything don't work, right? So that is it, guys. First look. I could with some feedback. Not really much feature request because like I said, every feature add is maintenance overhead. And more so, stuff for polishing, this the general quotes. If you put features, we'll consider some, but so this is where we are. So this is offline desktop. So I can recommend to, people to use and eventually build an ecosystem around, hoping, we could get some support to this from the community. So that's it, guys. Thanks for watching. Be on the lookout for this. This is the Rovari platform Circuit Studio for CircuitPython. And we have Rovari Studio and Rovari Studio Pro that is more for C, C++ workflows, especially for RISC-V devices. So one last thing I kind of started also working on porting CircuitPython to the WCH chips. I actually ported NotX. That chip has a drop system that kind of difficult, but that is a talk for another video. So subscribe, comment. I can really work forward on a san how get some feedback, right? So thanks guys and stay on lookout. Within 30 to probably 40-ish days, I'll have this beta. It's alpha right now, and put up a GitHub release and stuff like that. Thanks guys.